Let's talk about circles. We are going to start off with talking about perimeter of a circle, sector, arc length, and perimeter of a segment. The first thing we are going to talk about is perimeter of a circle. But before we solve the problem, I want to talk about perimeter a bit. Say you have a circle. The perimeter of the circle is simply this line, the outer part of the circle. Another name for the perimeter is the circumference of a circle. So we can call the perimeter of a circle the circumference of a circle. We calculate the perimeter by using perimeter is equal to 2 pi r, where r is the distance from this middle to the end. The perimeter is also another name for circumference, so we can also say the circumference of a circle is equal to 2 pi r. Pi is a constant value. So pi is often equal to 22/7. Let's jump onto the question and solve the question. So when given a question, the first thing you write is solution. The next thing is to read out your question and interpret the question. In this case, you are told that if the radius of a circle is 25 centimeters, find the circumference of the circle. Next up, you write out what you are given in the question. So givens, we are given our radius to be 25 centimeters, and then we are told to find circumference, C, or parameter of the circle. Next up, you write out the formula that you can use to find this. The formula that you can use is P is equal to 2 pi r. Except it's stated otherwise, pi is equal to 22/7. Sometimes they can give you as 3.142. Next up, to find our circumference, you simply say P is equal to 2 times pi, which is 22/7, 22/7 times 25. Here we can now see P is equal to 2 times 22 is 44 times 25/7 is equal to 1188 divided by 7. All of this divided by 7 is equal to 169.71 centimeters. This is to 2 decimal places, by the way. So this is 2 decimal places. Let's take another example. Okay, for this problem, you can decide to pause the video and solve it yourself. Like we did before, we write out our solution and then write out our givens. So what were we given in the question? To know our givens, we have to read the question. We are told to find the perimeter of the circle whose radius is 3 centimeters. So the radius of our circle is 3 centimeters. And then we are told to find the perimeter. Now we know that the formula we can use, perimeter is equal to 2 pi r. Now we know our pi is always 22/7. We can write pi here as 22/7. Now we know our r, so we can simply plug everything in to get our perimeter. So our perimeter is equal to 2 times pi. Pi is 22/7 times r. R is 3. From here we know that 2 times 22 is 44 times 3/7. So that this is equal to 44 times 3 is 132 divided by 7. 132 divided by 7 is 18.86 centimeters. So this is 18.86 centimeters, 2 decimal places. 2 decimal places, in case of you are confused of what this means, it simply means that 2 numbers after the point. I'll leave a link to the video here to explain approximation for you further. Let's look into another example. In this case, we are asked to find what is the diameter of a circle, given its circumference is 40 centimeters. We can see our givens. Since we know that our circumference to be 40 centimeters, we can also write down the perimeter. Perimeter is equal to 40 centimeters. Remember, circumference of a circle is also its perimeter. We have perimeter to be 40 centimeters. Now we are told to find the diameter. we know the formula for perimeter to be P is equal to 2 pi r. Now there's no diameter in this formula, so how do we even find diameter? What we do know is that diameter is equal to 2r. To help you understand what this is, if we're to draw a circle out like this, from the center to this point is the radius. Then from this point to the other point, if this is a complete straight line, that means this whole thing is the diameter. So that's the diameter will be r here plus r here. That's why diameter is equal to 2r. So to find our diameter, we need to first find r. From this formula, we are going to rewrite this formula. This formula is P is equal to 2 pi r. We have to make r subject of formula. So that if we divide both sides by 2 pi, we have this cancels out this, and r will be equal to P over 2 pi. Now that we made r subject of formula, we can now plug in our values into this. So that's r is equal to P is 40, and then we have 2. Remember, pi is always 22 over 7, so this is 22 over 7. From here we have r is equal to 40 divided by 2 times 22 is 44 divided by 7. We can write this as saying r is equal to 40. Then we say use division sign to replace this long division here. So this is 44 over 7. Now in mathematics, if you have a division sign and you have a fraction after the division sign, you can change the division sign into multiplication by switching this fraction. So we switch the denominator with the numerator so that we have something like this. We now have r is equal to 40 times 7 over 44. Notice that after this division sign, I switch the denominator with the numerator so that I'll have r is equal to 40 times 7 is 280 divided by 44. Now 280 divided by 44 is 6.36 centimeters. Since r is 6.36 centimeters, that means this implies, or this means that d will be equal to 2r. And if d is equal to 2r, we know that 2 times 6.36. This implies that d is equal to 12.72 centimeters. So this is our final answer. Now that we've talked about circumference of a circle, let's talk about the length of an arc. Say we have a circle and this is the center of the circle. Remember we said the circumference is all of these parts outside of the circle. An arc is just a portion of the circumference. So an arc is when you cut the circumference into 2 parts or 3 parts. That's when you get an arc. So this is an arc. Just this part is an arc. If I cut here, just this part is an arc. If I cut here, just this part is an arc. And remember, as this part is an arc, this part is also an arc. If I were to just cut here, and leave out the rest, here is an arc, here is also an arc. So that means an arc is just like a portion of a circumference. So to calculate the length of an arc, we need to use something that gives us the portion of the circumference. To calculate this part of the circle, we need to get the fraction of this part of the circle. So that means an arc can be, say, if you say length of an arc, we normally refer to that as L is always giving us theta over 360. Why is it theta? Because theta tells us the fraction of this arc to the entire circle. For example, if you have a pizza and you slice the pizza into parts, theta tells you how much of the pizza was cut out. So this is theta over 360 times 2 pi r. To calculate the length of an arc, this is what you need to calculate. So the length of an arc simply gives us this distance here. Now remember that 2 pi r gives us the combination of everything, but theta over 360 times 2 pi r gives us just this part. Now that you know the formula for length of an arc, let's look into this problem. First things first, I'll write solution. The question says an arc of a circle with radius 14 centimeter suspends an angle of 135 degrees at the center. Calculate the length of the arc. What we are given, we are told that the radius is 14 centimeter. We are told that the angle is 135 degrees. Then we are told to calculate the length of the arc. So we are told to find L. Now if we were to do a rough sketch of this, the circle would look like this, and then this would be the center of the circle. This angle would be 135 degrees. Then we are told to calculate this length. The radius is 14 centimeter. Remember, the formula for length of an arc is given as L is equal to theta over 360 times 2 pi r. From here we have this is equal to theta is 135 over 360 times, we have 2 times pi is always 22 over 7, except stated otherwise. Here we have 22 over 7 times r is 14. From here we can start, we multiply the numerators and the denominators. You can see 135 times 2 times 22 times 14 divided by 360 times 7. 135 times 2 times 2 times 14. The answer to that is equal to 83,116 divided by, if we multiply the denominator, 360 times 7, we'll have 2,520. If we divide the numerator by the denominator, we have equal to 3 centimeters. So that means that the length of the arc in this problem is equal to 3 centimeters. That simply means that the distance between here to here is 3 centimeters. Let's look at another example. We are told that the radius of a circle is 28 centimeter and the length of an arc is 44 centimeter. Calculate the angles at the center. Let's say solution. For our givens, we have the radius is 28 centimeters. The length of our arc, which is L, is equal to 44 centimeters. We are told to calculate the angle at the center. So that means we have to find theta. The formulas we know that can help us find theta is L is equal to theta over 360 times 2 pi r. The subject of formula is L, but we already have L. That means we have to make theta the subject of formula. To make theta a subject of formula here, we write it as L is equal to, the numerator is multiplying theta here. This denominator of this term is 1. So this is 2 pi r theta over 360. We can cross multiply here so that we have 2 pi r theta is equal to 360 L. From here we can divide both sides by 2 pi r so that theta, this will cancel out this, and then theta will be equal to 360 times the length of the arc divided by 2 pi r. From here we can easily plug in our values to give us what we want. We know that theta is equal to 360 times our L value, or the length of our arc, is 44 centimeters. That means this is 44 divided by 2 times the pi is 22 over 7. This is 22 over 7 times r. R is 28. From here we have that theta is equal to 360 times 44 is 15,840 divided by, since we have fractions in the denominator, I'll use this as fractions, or write them as fractions, 2 over 1 and 28 over 1. The numerators here will be multiplying each other and denominators will be multiplying each other. This will be 2 times 22 times 28. That will be 1232 divided by 1 times 7 times 1 is still 7. From here, I know that theta, I can write this as 15840 divided by 1232 over 7. I have to change this to a multiplication sign, so I can say theta is equal to 15840 times, if I change it to times, I'll change the denominator and the numerator, so that this becomes 7 over 1232. This will now be equal to 15,840 times 7 is 110,880 divided by 1,232. That means that this is equal to 90. This is equal to 90. Remember, theta is almost always measured in degrees. Let's look at another example. For our third example, we are told that the length of an arc of a circle is 90 centimeters. The angle suspended at the center of the circle is 240 degrees. Calculate the radius of the circle. Write solution like we do normally, write out our givens. We are told that the length of the arc is 90 centimeters. We are told that the angle suspended at the center is 240 degrees. And then we are told to find or calculate the radius of the circle. The formula we know for this is L is equal to theta over 360 times 2 pi r. We know L, but we don't know r. The best thing we can do is to make r subject to formula here. To make r subject to formula here, you can write this as L is equal to theta times 2 pi r here is 2 pi r theta over 360. You equals multiply, so that you have 2 pi r theta is equal to 360 L. R here, you can divide both sides by 2 pi theta, so that you have r isolated. R here is equal to 360 L divided by 2 pi theta. Next up, we already have r as a subject of formula. We can then substitute our values inside here. This would mean that r will be equal to 360 times L. L is 90 divided by 2 times pi is 22 over 7 times theta is 240, so that we have r is equal to 360 times 90 is 32,400 divided by, we can punch these numerators into our calculators first, so that we have 10,560 divided by 7, which is the numerator here. We can divide this and keep it on the side instead of doing the multiplication thing that we did before. So we can say this is equal to, if you do this on your calculator, you would have 32,400 over 1,508.57. So you divide this by this. The radius here would be equal to 21.477 centimeters. That means the radius of our circle here is 21.477 centimeters. So that's it on length of an arc. Let's move on to the next thing that talks about perimeters. Let's look into perimeter of sectors. Before we look into perimeter of sectors, let's talk about what sectors are. Say you have a circle like this. A sector is a portion of a circle that you cut out like this. So this part that you cut out is a sector of a circle. If you cut it out to look like this, now remember, perimeter is just the sum of the outer parts of a shape. Now this means that if you look at this, this is an arc, this is a radius, and this is a radius. So to find the perimeter of the shape, we need to find this length plus this length plus this length. Now we already know that the length of an arc is L. We call it L. We know that this is the radius and this is the radius. So that's the perimeter of a sector would be P is equal to the length of the arc here, which is L, plus this R, which will be R, plus this R, which will be plus R. From here, we know that perimeter is L plus 2R. This means that perimeter of a sector is the length plus 2 times radius, where we can still write the length as equal to theta over 360 times 2 pi R plus 2R. So you can decide to calculate the length separately and plug it into this formula. That's still okay. Another thing I would like you to take note of is that this part is also a sector. So if we still write it like this to still be valid, that this is a sector, as long as you cut it from the center of a circle and you have big portion of the circle, then you have a sector. Let's look into this example. We write out solution here. We are told to calculate the perimeter of a sector which subtends an angle of 90 degrees. That means our givens, let's write out our givens. We have theta is equal to 90 degrees at the center of a circle with radius of 21 centimeters. We know that our radius is 21 centimeters. Remember, our sector always looks like this. So apparently we have a 90 degree angle here and we have a 21 centimeter radius, a 21 centimeter radius. We do not know the length of the arc. We are told to find the perimeter. So we need to get this. We need to add this, and add this. Now what we are supposed to find is the perimeter of sector, P of sector. We know that P of sector is equal to L plus 2R, but we do not know L. So we have to go and find L. L is equal to theta over 360 times 2 pi R. From here, we know that L is equal to our theta is 90 degrees. We have 90 over 360 times 2 times pi is 22 over 7 times R is 21. This will be equal to, I'll be multiplying the numerators together. I know that 90 times 2 times 22 times 21 is 3,160 divided by 360 times 7 is 2,520. If I divide these two things, I have L will be equal to 33 centimeters. From here, I can write out my perimeter. So that my perimeter will be equal to L plus 2R. This will be equal to 33 plus 2 open brackets 21. My perimeter of my sector will be 33 plus 2 times 21 is 42. So 33 plus 42. The perimeter of my sector is 75 centimeters. So that is the perimeter of this sector I was given in the question. Let's look at another example. For another example, we are told that the angle subtended by a sector of a circle is 70 degrees. If the perimeter of the sector is 105 centimeter, calculate the radius. Know that the solution, research has a solution. Our givens. The givens we have here is theta is equal to 70 degrees. It helps to draw your diagram most times. So this is supposedly a sector and this is 70 degrees angle. We don't know our radius. But we are told that the perimeter of the sector is 105. What we can do is, we know the perimeter of the circle is 105 centimeters. That's all we're given. We're now told to find the radius. The formula we know is P is equal to L plus 2R. Now we know P, but we don't know R and L. We can write out L in terms of R, so that this will be equal to theta over 360 times 2 pi R plus 2R. So P will be equal to all of these things. Then we'll try to make R subject to formula from here to be able to find the radius. Now we know that this can be simplified as P is equal to 2 pi R times theta is 2 pi R theta over 360 plus 2R over 1. You can factorize R from here so that we have P is equal to R open bracket 2 pi theta over 360 plus 2. From here, still you can divide both sides by this bracket so that you have R is equal to P over 2 pi theta over 360 plus 2. From here, you have the get school to solve for your value of R. So the R will be equal to P is 105. Perimeter of this sector is 105. So we have 105 over 2 times pi. You have 2 times 22 over 7 times theta is 70 degrees divided by 360 plus 2. If you do this, you have R is equal to 105 divided by. So I'll just do here directly to avoid waste of time. If you do all of this in your calculator to avoid waste of time, this you can write it as 3080 over 7 times 360 plus 2. So this is the denominator, and then R will be equal to 105 over, if you do solve this, you have 1.2222 to about 4 decimal places plus 2, and then you have R is equal to 105 divided by 3.2222. So this is equal to around 32.586 centimeters. So that's the radius of a sector with this perimeter. Next up, we'll be looking into perimeters of segments. Let's talk the perimeter of a segment. Like we've done with the rest, before we solve the question, we need to look into perimeter of a segment. Say you have a circle and you have a chord separating the circle into 2 portions. This is a segment of the circle. This is also a segment, but I want to show you how to get the perimeter of a segment. The segment looks like this, and there is a center. Let's say the center is around here. There's a radius. This is the segment, mind you. So what we care about is this length. We care about the length of the chord here. We also care about the length of the arc. So this is L already. So we know that perimeter of segments is equal to L plus the length of the chord. Length of chord. So that perimeter of segments is equal to the length plus, how do we find the length of chord? So if we are given the angle from the center of the circle, if we divide this angle into 2, we have half of the angle. So here will be theta over 2. Here will be theta over 2. Then we have the radius. We already know the radius. If this is the angle, we'll have a triangle that looks like this. We draw it out. Theta over 2. This will be R. This will be half the length of the chord. So if you are looking for this point, remember this is the portion of the chord. So if you're looking for this part, we can use sine theta to find it. So that this will look like sine of, if we call here x, this will be sine of theta over 2. The angle here is theta over 2 is equal to opposite, which is this one, x over r. this would imply that x is equal to r sine theta over 2. Remember, what we just got is half of this. To get the other half, we need to multiply this by 2, right? So that the length of chord will be equal to 2r sine theta over 2. All of this comes in together when we say the perimeter of the sector will be equal to length of the arc, which is this length here, plus length of the chord. So that means L plus 2r sine theta over 2. So this is how you find the perimeter of a segment. Let's look at the example here and try to solve the problem. For the solution, we are told to calculate the perimeter of a segment which suspends an angle of 90 degrees and the center of a circle of radius 3.5 centimeters. This would simply mean that we have our givens. The theta we have on our hands is 90 degrees. The radius we have on our hands is 3.5 centimeters. We are told to calculate the perimeter of the segments. So find perimeter of segments. Let's call this P. We know that perimeter of segment is length of arc plus the length of chord. So I'll say length of arc for LA, length of chord for LC. If I write this, I'll say this is equal to length of arc is theta over 360 times 2 pi r. Remember, our length of chord is automatically 2r sine theta over 2. So if I plug in my r values and the rest, I will have my perimeter as equal to theta is 90 over 360 times 2 times pi is 22 over 7 times r is 3.5 plus, be careful how you evaluate this to avoid making mistakes, plus 2 times r is 3.5 sine 90 divided by 2. Here we have P is equal to 90 here is 1, 90 here is 4, 2 here is 2, 2 here is 1. So that now that I've cancelled, I have 1 times 22 over 7, 1 over 2, 22 over 7 times 3.5. This will be plus here 2 times 3.5, 7 sine 90 divided by 2 is 45. And simply go into it further and say P, 2 here is 1, 2 here is 11. So I have 11 times 3.5 over 7 plus half times 7 times. From a calculator, sine 45 is 0.7071. Make sure you deal with this in board mass form. So deal with the brackets best. 11 times 3.5. This is P is equal to 38.5 over 7 plus 7 times 0.7071 is 4.9497. 38.5 divided by 7 is equal to 5.5. If you add up these two, 5.5 plus 4.9497, you have equals to 10.4497 centimeters. So that means the perimeter of our circle is 10.4497 centimeters. For the last examples under perimeters, we have a segment of a circle of radius 14 centimeter has an angle of 135 degrees at the center. Calculate its perimeter. The solution, our givens is r is equal to 14 centimeters. Theta is equal to 135 degrees. It also calculates its perimeter. So you have to find perimeter. Remember, perimeter of a circle, like we just did before, is the length of the arc plus length of the chord. If you put some two of this together, you have Length of the arc is theta over 360 times 2 pi r plus length of the chord is 2r sine theta over 2. We simply plug in everything we have here into here so that the perimeter be equals to theta is 135 degrees over 360 times 2 times pi times 2 over 7 times 14 plus 2 times 14. Be careful when you are dealing with these sides that you don't mix them up. Times sine, the angle is 135 over 2. If I multiply all the numerators here, I'll have perimeter is equal to 83,160 divided by 2,520 plus this is 2 times 14 for the sine is 28 sine 135. 135 divided by 2 is 67.5. So this side is 67.5. I divide this, I'll have P is equal to 33 plus, I do 28 sine 67.5 for my calculator. I have 25.87 to 2 decimal place. So that if I have perimeter is equal to 33 plus 25.87 is 58.87 centimeters. That's it on calculation of perimeters. The next topic we're going to look at is areas. Here we'll be talking about the area of a circle, segments, and sectors. First thing we're talking about is the area of the circle itself. But before we do that, I want to talk about the formula. And so if I have a circle, the area of the circle is simply the portion inside, all of it, all the portion inside. Unlike the circumference where you're looking at outer boundaries, the area is everything inside. The area of the circle is given as pi r square, and the units is in square. So if I say centimeter square or meter square, that's always the unit of an area, or kilometer square. Let's look at this example. First of all, we write solution. We are told to calculate the area of a circle with radius 5 centimeter. We are given the radius of a circle as 5 cm. We are told to calculate the area. The area is what we need to find. Find the area. We know that area is equal to pi r square. We can just simply plug in our r into this formula. Now, pi is always times 2 over 7, so we can say it times 2 over 7 times 5 square. This is equal to 22 over 7 times 25. 5 square is 25. This is 25 over 1. I can multiply the numerator, so that I have 22 times 25. Divide by 7. My area would then be equal to 22 times 25 is 550 divided by 7. If I divide this by 7, my area will be equal to 78.57 centimeter square. So like we've been doing before, let's look at extra example. For this example, let's write out solution. It will calculate the radius of a circle with an area of 22 centimeters squared. We write out the perimeter. So what are we given? We are given A is equal to 22 centimeters square. We are told to find R. We know that the formula we know about area and R is area is equal to pi r square. We can make R subject of formula. So to make R subject of formula here, we divide through by pi. If we divide through by pi, r square will be equal to A by pi. Next thing, you take the square root of both sides. So this square root of r square, this cancels out this. This is square root of A over pi. So that you have r is equal to square root of A over pi. You simply substitute the values of A and pi here, so that you have r is equal to square root of 22 over pi is 22 over 7. 22 divided by 7. So r can be written as equal to square root of 22 divided by 22 over 7. You can change the division sign by switching the denominator here with the numerator. That would mean that you have r is square root of 22 times 7 over 22. This cancels out this, and you have r is equal to square root of 7. R is a unit of length, so that we can say this is square root of 7 centimeters. Or we can rewrite this in decimal place and say r is equal to 2.65 centimeters. Let's look at examples under areas of sectors. Like I've been doing before, to know the formula for area of a sector, we look at the circle. So a circle is like this, and we know that a sector is a portion of a circle carved out from the center of the circle. So this is a sector. The area of the entire circle is pi r square. The area of the sector will be the fraction of the sector times the total area. That would simply mean that the area of sector for us would be the fraction that this makes of the entire circle times the area of the entire circle. So this will be theta over 360 times pi r square. Now that we know the area of a sector, let's look into this problem. For this example, we are told that a sector of a circle, radius 21 centimeter, subtends an angle of 70 degrees at the center. Calculates the area of the sector. Let's write out solution. Our givens, we are given our radius as 21 centimeter. That means r is 21 centimeter. We are given our theta as 70 degrees. And then we are told to find the area of the sector. The formula that we know to use for area of sector is A is equal to theta over 360 times pi r square. We simply plug in everything here into here. If we do that, we have A is equal to 70 degrees divided by 360 times 22 over 7 for pi times r is 21. So 21 square. From here we have, if we multiply all the numerators and the denominators by themselves, we have equal to 70 times 22 times 21 square. Bracket this divided by 360 times 7 is equal to, for the numerator we have equal to 679,140. For the denominator, 360 times 7 is 2,520. If we divide this by this, we get 269.5 centimeters square. Let's look at another example. For this example, we are told that a sector of a circle, radius 10 centimeter, subtends angle 90 at the center. Calculates the area of the major sector. This is a key part. Let's start off with solution. To really be able to solve this question, you need to understand what the major sector is. So say we have a circle and you have a sector. Supposing the sector that we have is a 90-degree angle. If this is a 90-degree angle, that means this part will be 360 minus 90. 360 minus 90 is ultimately equal to 270 degrees. A major sector is the sector which has the higher angle. If you compare this one, which is 90 degrees, versus this one, which is 270 degrees, the 270 degree is the higher angle. So we're using our theta as 270 degrees. instead of 90 degrees because of the simple fact that we are told to calculate the area of the major sector. I'll write it as theta m to show that it is theta for major sector is equal to 360 minus theta, which is the theta we are given from the question. So I'll say theta m is equal to, this should be our givens anyway. Theta m is equal to 360 minus 90, and this is equal to 270. The radius we are given is 10 centimeter. Then we are told to find area of major sector AM. So the area of major sector is simply AM is equal to theta over 360 times pi r square. So here will be theta m because we're looking for the area of major sector. So area of major sector is equal to 270 divided by 360 times 22 over 7 for pi times 10 square. This is equal to, if I multiply the numerators by themselves, I have 270 times 22 times 10 square divided by 360 times 7. If I multiply all the numerators, I'll have 594,000 divided by 360 times 7 is 2,520. So that if I divide this by this, I simply get my area of my major sector to be equal to 235.71. Remember, the unit of area is, in this case, because the radius is in centimeter, the unit of area will be in centimeter square. That is it on areas of sectors. Let's move on to the next thing. Let's talk about areas of segments. But before we talk about area of segments, I'd like to show you the formula for area of a segment. So say we have a circle and this is center of the circle. We know that a sector is formed when we draw a chord. How do we find this area? The way we can do that is to link it to our radius and link it to our radius so that we can pull out this sector out. If you pull out this sector, we'll have something like this. But remember, what we care about is the segment, not the sector. So how do we get the area of the segment? We can get the area of the segment by doing area of segment is equal to area of sector, which is the area of the entire thing, minus area of this triangle, so that we can get the area of the segment here. So minus area of triangle. We know that area of sector is equal to theta over 360 times pi r square, minus area of the triangle is half r square sine theta, where the theta is simply the angle here. So now that we've spoken about the formula of a segment, of area of a segment, let's look into this example. Let's write out the solution first. If we read out the question, we're told that a segment of a circle whose radius is 7 centimeter subtends an angle of 135 degrees at the center. Calculate the area of the segment to 2 decimal places. You're told that the r, our radius, is 7 centimeter, and the segment that we spoke about has a theta of 135 degrees. We're now due to find the area of the segment. So find area of segment. So we just find it 2 decimal places. We know that area of segment is equal to area of sector. Area of sector is theta over 360 times pi r square minus area of triangle, which is half r square sine theta. So if you plug everything here, we know that area is equal to 135 over 360 times pi, which is 22 over 7 times 7 square minus 1 over 2 times 7 square times sine 135. From here, we know that area is equal to, so I'll be grouping this together to avoid mistakes. If I multiply all the numerators here, I get 135 times 22 times 49 over 360 times 7. Can bracket that. If I multiply the numbers here, I get 24.5 times sine 135. I multiply all the numerators here. 135 times 22 times 49 is equal to 145,530 divided by 2,520 minus 24.5 times sine 135 is 17.3241. If I divide this numerator and my denominator, I have area to be equal to 57.75 minus 17.3241. So I can safely minus here. If I subtract, I'll have A is equal to 40.4259. Remember, I was told to leave the answer in 2 decimal places. 2 decimal places meaning 2 numbers after the decimal. So this is the first number, the second number. That means I have to stop here. But before I do that, I need to approximate this number and add it here. If I approximate 5, it will round up to 1. So if I add 1 here, it will be 3. That means this is equal to 40.43. Remember, area is measured in centimeter square to 2 decimal places. So that's it. That's how to calculate the perimeters and areas of sectors, segments, and a circle as a whole. If you like this video, leave a thumbs up, share with your friends, and subscribe to this channel. Thanks for watching.